target number 2 in the chemistry unit. Target number 2 states that you can use the periodic table to determine the number of each subatomic particle for any element. Well, just quickly to review, a subatomic particle is the particles that make up an atom. So the electrons, the protons, and the neutrons are all subatomic particles. So let's take a look at one of the homework assignments that you guys had during this unit, and that was the Atoms Family Atomic Math Challenge. And this is typically what you'll see when you look at a periodic table of elements. And I'll go to one of the ones that I used in class. This is an example of the periodic table of elements, and here's nitrogen. And some of these periodic table of elements will show the atomic weight or the atomic mass, which is the number of protons plus neutrons, as a whole number, and then other times you'll see it as a fraction. And so this example shows that oxygen has an atomic weight of 15.999. Okay, and then here we have the atomic number of 8. So the atomic number is simply the number of protons. Okay, so this is the atomic number, and this is the symbol, and this is the element name, and then this is the atomic mass. And you'll have to forgive my writing, as this is the first time I've ever used this pad. And so the atomic mass equals the number of protons plus the number of neutrons. Okay, so if we're going to determine the number of protons or the number of electrons for any one of these, it's a fairly simple process. The atomic number is a number that's above the element symbol, and let's start with zinc here. So the atomic number that we have here is 30. Okay, that's because that's this number right here. Then we have the atomic mass. This is the atomic mass, 65.39. Okay, and then the number of protons. So the number of protons is always equal to the atomic number. So in this case, it's 30. So every atom of zinc in the entire universe has 30 protons. The number of neutrons, okay, this is how we get the number of neutrons. So you take 65.39 and you round it to the nearest whole number. So 65, and then you subtract the number of protons from it. Okay, so in this case it's 30. So 65 minus 30 equals 35. That's how you get the number of neutrons. So to review real quickly, I rounded this 65.39 to the nearest whole number, which is 65. I subtracted the number of protons from it. So for you math people, the atomic number is the number of protons plus neutrons. And if I subtract the number of protons, what I get is the number of neutrons. And then the number of electrons, we assume that this is electrically neutral, so the number of electrons is always the same as the number of protons. If I ask you a question such as, let's look at lithium. Let's say that I ask you a question about lithium, and the question says, will lithium, let's just pull this up here so it's a little bit bigger for you guys. Okay. So let's say that I ask you how many electrons or what kind of charge would lithium like to have. Well, since lithium is in group 1, it has 1 valence electron. And in order for it to be happy, it has a choice. It can either have gain 7 to get 8 electrons, so it behaves like neon, or it can lose 1 in order to behave like helium, and therefore fulfill the octet rule. So it would rather lose an electron. And if lithium loses an electron, then it then has a positive charge. Okay, and that is all for